Help word time. It looks like the only ones supplying us problems here are Ashley and Adrian. Put a couple up. So here we go. I hope these are problems that everybody needed since you didn't put problems up. My fear is that you knew we weren't going to have class, so you fell behind and you're not caught up on the lessons. So we can't do that. We need to keep up with what we're doing so that we can finish the course. And so you don't get behind. So let's start with, this is lesson 93, number 3. It's a boat in the river problem. It says the hydro could go 40 miles per hour on the lake. The same boat could go 200, let's see, is this the right problem? Let's see. I think I did the wrong problem here. Okay. So let me try again. I did the wrong problem, but I think we'll be okay. All right, so the hydro could go 40 miles per hour on a lake. The same boat could go 210 miles down the Ekani River in half the time it took to go 300 miles up the Ekani River. How fast did the Ekani float? Okay, so here we go. We're going to just put in these numbers. The hydro could go 40 on the lake. So we know what the boat is. So for both of these cases, it's 40. I actually did problem number 2 for some reason. All right, so both of these are 40, the boat. All right, so we're just filling them in. It says the boat could go 40 miles on a lake. The same boat could go down the river, so this would be the down one, 210 miles. In half the time that it took to go up, we'll have to get with the time in a minute, 380 upstream. All right, we don't know the water, so we are going to put that in as W. Both of these we're going to have 2 variables left over. It took, let's see, the boat could go 210 miles down in half the time. So we're just going to make the up go twice as long. I just like working with whole numbers rather than partial numbers. So let's just put this in 2t, and then this is just going to be t. I think that's going to work. So time downstream is t, the time upstream is 2t. So let's just multiply that through. So we get 40t plus wt, and this is going to be 380 equals 80 t minus 2wt. We're going to solve these simultaneously. Let's see, is there anything that we could divide? We could divide this one by 2. I'm going to do that. Remember I was teaching you to try to reduce your equations. It just saves a little bit of work because the numbers are going to be smaller. Now we have a plus wt and a minus wt, so I'm going to line these up. 190, 40t, 40t minus wt. So we're going to get 400 equals 80. I can do better than that. 80t. And then we're just going to divide both sides, or we're just going to divide both sides by 80. So it's 400 divided by 80 is 5. So the time is 5 hours. What are they asking in the question? How fast did the river flow? All right, so the speed of the river is, we're just going to have to plug this in somewhere. I'm going to look for the easiest place to plug it in. Maybe I'll just plug it in right here. So 190 equals 40 times 5 minus w times 5. So that's going to be 200. So if I subtract 200 from 190, it's going to be negative 10 equals negative 5w. The water is 2, and we're talking miles per hour. Miles per hour. So I'm just going to double check that. 93, number 3. Yes. Okay. So that's all they're asking was the water. The boat ends up being 10 miles per, no, they just asked for that one, 2 miles per hour. So that was right. So that one was a little different. Okay, let's go on to lesson 93, number 9. So this one is just graph this on a number line. This is a conjunction, so it's going to be colored in between. The domain is the integers. So we're going to put dots on it. We're not going to color it the whole way in. First thing you need to do is solve for x. So I'm going to add x to all three parts, add 4 to all three parts, and we're going to get 1 is less than x is less than 6. So when we do our number line, I'm just going, the x is in between 1 and 6. These are integers though. So if we have 1, 2, 3, 4, 5, 6, we're not actually going to color in the 1 and the 6. If you feel more comfortable putting an open circle, that's fine, you don't need to. But here's your graph. It's going to be the ones in between, the integers in between, colored in. So that was pretty easy. But if you didn't know how to do it, I can understand why you'd miss that one. Okay, the next one is number 11. Lesson 93, number 11. A little bit more complicated. We have a circle, x squared plus y squared equals 1, intersected by a line x minus 2y equals 2. Now, this is a substitution problem because we have a line which we can solve for x. So we're going to get 2y plus 2. I'm going to solve it for one of the variables. X is the easiest one to solve for, and I'm going to plug it in where the x is. So we are going to get 2y plus 2 squared plus y squared equals 1. I'm going to do the mature way of foiling this. So 4y squared, multiply 2y times 2, you get 4y, then take that times 2, so we're going to get 8y, plus 4 plus y squared equals 1. And we're going to bring everything, it's quadratic, so I'm going to combine and I'm going to bring everything to the left. So we get 4y squared, 5y squared. Need to add our 4y squared and our 1y squared, so we get 5y squared plus 8y. And if I subtract 1 from 4, we're going to get plus 3 equals 0. This is actually, you could use the quadratic formula, but this is actually factorable. We could get 5y and y, 3 and 1. And I know this is right because if I check my outer, I get 5y. My inner is 3y, and that adds up to the middle, which is 8y. Now, each one of these we're going to set equal to 0. And y plus 1 equals 0. And we get y equals negative 3/5 and y equals negative 1. You do need to go back and get your x values. So if I put the 1, we're going to get negative 3/5 for our y. If I put that back in, if I take that, put it right here, I'll spare you the gory details, you get 4/5. And if I put negative 1 back in here, I'm going to get 0. So those are the 2 points where the line intersects with the circle. All right, done with 93. Let's go on to lesson 94. So lesson 94, number 16. All right, an I problem. Number 16. We have 2i plus 7 over negative 3i. So we can't have an imaginary number in the denominator, so I'm going to multiply the numerator and the denominator by I. You could do 3i, but it doesn't really help any. So in the numerator, we're going to distribute that through, so we get 2i squared plus 7i all over negative 3i squared. I squared is equal to negative 1. You need to know that for the SAT. So we're going to get negative 2 plus 7i. The same thing down here. I squared is negative 1. Negative 1 times negative 3 is going to be 3. And you just want to separate this out into the real part and the imaginary part, and that's called a complex number. So that is lesson 94, number 16. All right, number 20. Lesson 94, number 20. Number 20 is write negative 4r plus 8u in polar form. All right, so this, you just kind of want to graph to see where you're at. So this is your y-coordinate, your x-coordinate. You're going over 4, and then you're going up 8. Kind of like that. It's going to be in this quadrant. That's the main thing you have to know. So this is 4, and this is going to be 8. So you have to use a Pythagorean theorem to get the hypotenuse. So we're going to get 4 squared plus 8 squared equals c squared. And when we add those together, we're going to get 16 plus 64 equals c squared, and you're going to get c squared equals 80. C equals the square root of 80, which simplifies to 4 root 5. All right, that's this part of the polar coordinate. And then we need the angle. So remember the angle, we use the inverse tangent of this is your angle right here that you're looking for, kind of. So it's opposite over hypotenuse. When you pop that into your calculator, inverse tangent of that, you get 63.43. Now here's the issue. That's this angle right there. We want, when they're putting it in polar form, we want this angle. So I need to take and subtract that angle from 180 to get our final answer, which is going to be 116.57 degrees. And that's your final answer for that. And then finally for that lesson, we have lesson 30. Number 30. So let me just turn the page, see what that is. Ooh, this was a strange one. Lesson 94, number 30. They leave it in a weird form in the back of the book, which I guess it's okay if that's how they have it. 4 times x squared minus 9 minus 3x minus 3 plus x. So what you want to do is factor this. You get x plus 3x minus 3. And if we reverse these, keeping the same sign, it looks like this one, so we're okay. So common denominator is going to be x to the 4th. Is it x to the 4th? I copied that wrong. It's a to the 4th. A to the 4th, x to the 3rd, and then it's going to be x plus 3, x minus 3 is your common denominator. The 3 needs the x plus 3, x minus 3. The 4 needs all those little variables, a to the 4th, x to the 3rd, and the 3x needs the x plus 3. That's basically how they left it in the back of the book. The only thing they did differently is they said x squared minus 9. But this form would be fine since they didn't multiply anything else out. All right, that was it for lesson 94. Lesson 95. So we're going to start with number 11. I might have forgot to do 19. Let's see. Number 11, we're going to graph. X is greater than negative 2, and 2x plus 3y is greater than negative 3. And we're going to see where they overlap. First thing, in order to graph these, let me just put my axes on here real quick. Like this, y and x. X is greater than negative 2. If it's x, it's going to be vertical. So we're going to go over here, negative 2. It's going to be a dotted line because it's not and equal to. So we're going to do a dotted line coming down here. Not very straight. It's really hard on here. And it's greater than, so I'm going to color in this direction. Greater than. X values are greater. All right, so for the next one, it's a line, which you need to put it in y equals mx plus b form in order to graph it. So we're going to get 3y is greater than negative 2x minus 3. And then divide everything by 3. So y is greater than negative 2/3 x minus 1. So let's go down here. Let's get our negative 1. We're going to go down 2 over 1, 2, 3. And we're going to connect those. Again, it's going to be a dotted line because it's not and equal to. And it's y is greater, so it's going to be above here. So it's going to be all these colored in. And we are going to overshade where they where they overlap. So let me just pick another color, and they overlap all here, like this in here. So it's kind of, I kind of crossed the line. I shouldn't have crossed the line. So it's going to be like this. And that's it. Okay. Next one. We have lesson 95, 13. Is one of these guys. I'm surprised. Well, of course, it's just Ashley's questions, so I don't know what happened to the rest of you guys. We need to put forth some effort here. It's scaring me a little bit. A to the x, x to the a. Talk about tricky. Okay, distribute power to power, so we're going to get a to the 1/2 x plus 1. I'm going to bring this a to the x. I'm going to subtract that x off because we have an a, so I'm going to subtract it off. And here we have x to the 2a, and I'm going to subtract this a. And we just clean it up. So 1/2 minus 1 is going to be negative 1/2 x plus 1, and this is going to be x to the a. That's it. I made that look really easy, didn't I? Yep. Okay, number 17. All right, another I problem. Same thing, lesson 95, number 17. We have 4 plus I over negative I. We are going to just take top and bottom by an I, because that'll make an I squared, and that's no longer imaginary. On the top, we're going to get 4I plus I squared all over negative I squared. I squared is negative 1, so I'm just going to put the negative 1 out front because you should put the imaginary part second. This is just going to be a negative 1, so it's just going to be over 1, so this is your answer. All right, 19. I did not do this one ahead of time, but I will do this for you anyway. So just be patient with me. I'm going to have to use my calculator. 95, 19. So we have vectors. So we have like a lower vector. So it's in this fourth quadrant. We have a vector going, let's just do my orange vector. Going this direction. All right, put the arrows on the end. And then we have another vector going down 35 degrees. So, whoops, I didn't use a line, but you get the point. Okay, so this is 35 degrees. So we are trying to find the force acting. This is 12, and the orange one is 14. Now this one's on an axis. It's only going right. It's not going up and down. So for the orange one, it's going to be 14 right plus 0 up. A little bit of work for the blue one. So we have to make our little sides here. This is your y. This is your x. It's not the 14 necessarily, so we don't need to say the 14. We're just going to say x up there. So remember this. X equals 12 cosine of 35 degrees, and y equals 12 sine of 35 degrees. Okay, the vector's going to the right, and it's going down. So our right is going to stay positive. So let's do 12 times the cosine of 35. And we get 9.83 right. Now we're going down for the y. So we're going to do the same thing, 12 times the sine of 35. And we're going to get, even though in your calculator it comes out positive, we're going to do negative 6.88. We will draw a line, and this is going to be the up. So we're just going to add those up, and we're just going to go with that answer. So we're going to add 14 plus 9.83. We get 23.83 right minus 6.88 up. I don't know if they put that back in polar form or not. That's a lot of work. 95, 19. Nope, they do, but they let you leave it like this. So this is your final answer for this. The main thing is you have to make your y, since the y is going down, you have to make this negative at the end. All right, last one for this lesson. I didn't know if Adrian was wanting 1 and 3 or 13, so I'm going to do 1 and 3. I'm just going with it. So lesson 95, number 1. We have this weatherman Bob walked to the campsite 6 miles per hour. Then he caught a ride home, 24 kilometers per hour. If he's gone for 10 hours, how far was it to the campsite? For my book, it's lesson 22, so I know it's an old distance problem. So we have this distance, and then we have this distance. So the same distance, equal distance. So which way? We need some variables here. He walked to the campsite and then home. So let's do distance campsite, distance home. We know they're the same. Distance campsite equals distance home. Then we have rate campsite, rate home, time home. We're going to fill in the things. He walked, the rate to was 6 kilometers per hour, 6. The time, so he's gone, so time campground, time home equals 6. Ooh, that's really bad. I can't take that. Hold on. Time campsite plus time home equals 10. So let's do time campsite equals 10 equals, hold on, time campsite equals 10 minus time home. So the time campsite is 10 minus time home. The rate home, does it tell us the rate home? 24. And it would be time home. And so we're going to get 60 minus 6 time home equals 24 time home. And that's really messy, I'm sorry, but we're going to get 60 equals 30 time home, and the time home is going to equal 2. And so then we have to see what they're asking for. And they want to know the total distance. So you have to take time home, which is 2, times the rate home, which is 24. And so it's going to be 48 kilometers. There you go. I did number 1. Okay, number 3. Lesson 95, number 3. Oh, pressure. P1 V1 over T1 equals P2 V2 over T2. Okay, the tricky part for this one, of course, is you have to, it says here that you have to add 273 degrees to convert Kelvins, Celsius to Kelvins. The other thing is we know the volume stayed. The pressure, who stayed? The pressure was held constant. So we can just ditch that. So it's V1 over T1 equals V2 over T2. And then I'm going to fill in the numbers. 400 for volume 1, temperature 1, I added the 273, so it's 473. Volume 2, they say to solve for V2 first, but it's pretty easy. Cross multiply, this times this divided by this, and you get the volume equals 738.27 milliliters. All right, finished lesson 95. Finally, lesson 96, we only have 2 problems on that one. So lesson 96, we have 2 and 4. I know you guys had more problems than this. So jointly thing jointly. Okay, let me see where I did this. Okay, so I'm just going to do it the one way. You're supposed to do it both ways. So number 2, spinners varied jointly as ratchets and miters. If 100 spinners, so first we're getting K, went with 4 ratchets and 5 miters, we're going to get K equals 100 divided by 20 is 5. Then they say how many ratchets would go with 20 spanners, not spinners. So it would be 20 spanners. We have our K is 5. We don't know how many ratchets. And we have miters are 2. So if I divide, this is 10. 20 divided by 10 is 2. So the ratchets equal 2. All right, that was interesting. All right, last problem. This is the answer. All right, last problem, another distance problem. Lesson 96, number 4. Okay, this one is a 300-mile trip, took 5 hours longer than the trip home. If the speed coming back was twice as great as the speed going, find both speeds and both times. Okay, this one's a little tricky. They give you the distances. So it's like even though they're equal distance, we have to set it up like this, 300, 300. All right, so what variables are we going to use here? Let's see, the trip to, I'm just going to call that distance 2, and this one the distance back, distance back. All right, so let's just make up our equations. This is distance 2 equals rate 2 time 2. This is distance back equals rate back time back. They tell us some things, I think. They tell us, let's see what we got here. If the speed, okay, so the trip to, so the time to equals 5 hours longer than the trip home, equals a time home, I guess back, plus 5. And the rate back equals 2 rate, twice as much as the rate 2. Now these are solved for different variables. We have the t and the b. So I'm going to take this equation and solve it for the t sub b. So t sub b equals t sub t minus 5. So now I have both of these solved. I have the rb and the tb, so I'm going to use this equation. We know the distance is 300, so we'll say 300. rb is 2rt. tb is tt minus 5. Now we're going to distribute it through. So we get 300 equals 2rt tt minus 10 rt. Whew. Now we know rt tt right here is 300, the distance. So we're going to substitute that in, 300. I think I can scroll this down. I think I have more space than I know. 300 equals 2 times 300, because that's RTTT is equal to 300 minus 10 RT. So this is going to be 600 subtracted from 300 is going to be negative 300 equals negative 10 RT. Divide both sides by 10 and we get RT equals 30. And what are they asking for in the question? They are asking find both speeds and both times. Well, I got the speed for you, miles per hour. You can start plugging everybody back in. You take this up here, put it in 4 there, and you would get time would be 300 divided by 100, which would be this. You can figure that out. So this is going to be 300 divided by 30, and that's going to be 10. So you can take it from there. That would be the time, so it'd be hours. And then you go over here and substitute those in. Okay, that is it for the homework. We will see you in class tomorrow at 8:30. I don't know where this started, guys. This is lesson 90 something, 93 to 96.